Okay, so you're gonna start on tangent functions, and if you want to, you can pause this video first and try to fill out the tables of values first below. But if you're stuck, you can come back to this and you can see a bit of explanations. Now you should be using your calculator to try to fill out these values. So you just sub in the values of x, and you will get a tangent value here. Alright. So the first one, I'm gonna start with the positive one because it's easier. So this is gonna be 0. And if you do tangent 45, is actually 1. We know this from the basic angles. And when you try to do tangent 90, you will have a math error on your calculator. Okay? And when you have a math error on your calculator, just means that this is gonna be undefined. Oh, how is that possible? But don't worry, let's just go on first and try different things. Okay? So what about tangent 135 is gonna be -1. And then you try 180 is going to be 0. Okay, you just keep trying here and there. And then 225 is going to be 1, and this is going to be undefined again. Okay, so at 270 degrees is going to be undefined, and this is going to be -1, and this is going to be 0. Okay, now doesn't really make sense, but let's try going backwards. Okay, also, right? So if you try going backwards, okay, you will realize that tangent of -45, which is what we learned in the previous part, okay, it gives you -1. It does simply gives you -1, and tangent of -90 will give you undefined. Okay, and then we will have tangent of -135 will give you 1, and this will give you 0, -1, and it goes on and so on. Okay, undefined. And it's very interesting, there are certain angles that is going to be undefined. You can keep going on, and you're just gonna get this, and at certain angles it's gonna be at 0. Okay, if you think about it, right, can you if we look at here, if it's 180 degrees, doesn't matter negative or positive, it is going to be 0, and of course 0 lah. 0 itself is 0. Okay, and then we look at 270 degrees, 90 degrees, and if it's 270 and 90 degrees, it's going to be undefined. And the rest, which is in the middle of 180 and 270, or in the middle of 270 and 360, or so on and so forth, is going to be 1 or -1. So what does it actually look like for us on the graph? Okay, I'm going to plot the points, and then you try to make some sense about it. So if it's undefined, there's no point to make. Okay, so it will look something like that, and then on here it will just look something like that again. Okay, this is 135, and they will look something like that. Right, and then it's undefined again, and this is -1 if I'm not wrong, so you look like that and like that. Okay, but we're not going to care about this. I'm going to go to the backwards, so you'll realize that this is going to be the same thing. 180 degrees is 0. This is going to be here, and this is going to be here, undefined again. This is going to be here, and this is going to be here. Now, the thing is, because it's undefined, right? At this point, it's undefined, right? You cannot connect this to this. It's not possible. Okay, this is wrong. So actually, if you use Desmos, you're trying to look at. Okay, you're gonna go on using Desmos, right? Okay, so if you use Desmos, okay, and try to see what the graph of tangent x looks like. And it's going to be a very interesting function. It will look way different from what you understand about this, and it will just look something like that. And you realize that it actually is a repeated graph. It's an infinite graph again, but it's not infinitely this way anymore. It's going to be infinitely this way. And it's a very interesting pattern we see here. So the problem is, how on earth are we going to sketch it, right? Oh, okay, I cannot increase my. Okay, I'm gonna do that. Okay, so we just bear in mind that this 0, this is at pi. Okay, at 1, this is gonna be at the 45-degree mark. So what happens here, because it's undefined at 90 degrees, 270 degrees, there is something called an asymptote. Okay, asymptote is not part of the graph, but it's a dotted line that we want to draw to help us with drawing it well. So because it's undefined at 90 degrees, I'm going to draw a dotted line at 90 degrees, okay, that at the values that are undefined. something like that. Okay, so duplicate this. Okay, we'll do it also for 270. Duplicate this, we'll do it for the negative 90 as well. Duplicate this, and we will do it for 270 degrees. So from here, what we're going to do is we're going to use it according to what was given to us earlier in terms of sketching it. I'm going to start with this one over here. If you look at Desmos very carefully, you look at Desmos very carefully. Okay, it's like, hey, you actually go up this way, go up here. Okay, you cannot really see, but you're actually going up from 0 upwards, like a little bit like an exponential graph, but it's not exactly an exponential graph. And then you're going downwards there. So what happened is you're going to draw from here. It's going to start from here, go up, and hit this point, and you approach the 90-degree mark, but it will not touch it. Okay, you may have some problems drawing it at first, like me right now. Okay, especially if the graph is not well done for you. Draw it up here, go up, and it will approach the 90-degree dotted line as though that it's touching it, but it's not going to touch it. Okay, this is what it means when it's undefined. You approach the 90-degree line, and we call these lines actually asymptotes. Asymptotes are invisible lines that graphs tend towards. Tend means it goes towards, but it will not touch them. So we use these asymptotes to help us. Okay, we'll do the same for here, but you realize that as you go past 90 degrees, there's a change in the way it's drawn. Okay, so you will come down something like that. Okay, maybe I need to just make this a bit longer so you can see how it looks like. So something like that. So it goes down like that. Okay, I think I didn't draw it very well, so I'm gonna redraw this part because I think it's not very well drawn. Yeah, it's a bit like too wobbly. Yeah, it's a bit too wobbly, but it's fine. Okay, it approaches, so it looks it does not look very good. No, it doesn't look very good. That's the problem with your iPad, because they tend to like not draw your lines very well. Okay, I'm gonna try it here. Oh no, don't rotate. okay, let's try it from here. It looks so much better. Okay, it looks so much better now. Okay, so that's how you draw this. Now you're gonna repeat these for the rest of it's just gonna look like that. And later we will talk about decreasing it later again, but that's actually how it looks like. So we're gonna repeat this. It's a bit of a hassle, but as I said, it's just going up exponentially. So start from here and go up, reach here, and then when you hit 0, it will come down, touch here, go down. Okay, that's not very good. Try again. Go down, come down. Okay, just about there. Okay, for this, it's also going to be the same. Go up like that. And then from here, it's also going to be the same. I always tend to always draw from the positive side first. Okay, because it's a little bit tougher to draw this part. Okay, because it has to tend towards that, which is difficult. Okay, which is really tough. Okay, there's a point in what we call a change in terms of direction, in terms of rate at which it changes. So, but you don't have to worry about that first. But you just need to realize that I'm not drawing straight lines. I'm drawing curves. I'm still drawing curves. It has to be a curve because this is not a linear function. So if it's not a linear function, this is it will not be a curve. It will not be a line. Okay, do take note about that. Okay, but okay, we're almost there. And so this is what it means to draw your tangent function. So this is how your tangent function looks, and if I were to translate this into the in the graph here, it will just simply look like that. It will just look something like that. Okay, you still have to draw your dotted lines, And whenever you draw your tangent function, it will be good to always draw your asymptotes, which is a very good practice in fact. Okay, a very very good practice, because your asymptotes are going to tell you, okay, where you should be drawing and where you should not be drawing. Okay, without your asymptotes, you cannot in fact make a very good sketch. Okay, so I'm just show you how I'm going to sketch it very quickly. I'm just going to assume that you will cut here, go up here, and then it goes up very quickly. You don't have to make it like super nice when it comes to a sketch, but you just need to make it look like it's of the correct shape. Something like that. Okay, and something like that as well. Oh, I missed it. Okay, that's why you should always use an eraser to cancel it. Something like that. And for here, it's just simply here outwards. Oh, it looks weird. Okay, something like that. And from here, it's just okay. Something like that. Okay, so that's how you draw your tangent. Oh, sorry, just change this to tangent. I forgot to change it out. Okay, so you can answer all these questions very straightforward. I think it's quite important to know for which values of x that tangent x is equals to 0. You in fact have all the 0 degrees, all the 180 degrees, and 360 degrees. So all the 2 pi, 4 pi, like pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, all these are all going to be 0. When is it? When is tangent x equals to 1? You have 45 degrees is equals to 1. Okay, you have the point where it's 225. So all this in the middle, all the angles now in the middle. So it's very different from earlier. And then when are the points which are -1? You have 135 and 315 degrees. For which values are of x in which x is undefined, it's going to be 90 degrees and 270 degrees. Maximum value? Is there any maximum value for graphs like that? Think about it, it's going infinitely stretching upwards and downwards. So there will not be any undefined. There will not be any maximum or minimum value. So that's something interesting. So no matter how you multiply to tangent x, it will just keep increasing. Right? Period. Number of degrees to form one cycle is there a period? Now if you think about it, the period is actually going to be from what one cycle just looks like what? For a tangent graph, one cycle looks like this. This is one cycle, right? So how much is it to take one cycle? It's actually about from -90 degrees to 90 degrees, and that is your that is it. Alright, that's a period. So your period is actually 180 degrees here. Okay, because between -90 to 90 degrees, it's about 180 degrees. Any axis of the curve? Many axes of the curve, but you realize it's always actually not really. There's not really gonna be any axis to the curve in the sense. Okay, and is there any amplitude? Okay, in this case it's a no, because it stretches infinitely upwards, right? Vertically. So since it stretches, there will not be any amplitude, and there's no axis of the curve. So with that, right, we want to know how to like multiply it, right? So in this case, you realize that even if you multiply any value to the tangent, right, it's going to be the same thing. Okay, so this is like because remember you multiply a value to the tangent of trigonometry function, thinking you can multiply the amplitude, but in this case there's no amplitude to multiply. It's infinite, so it's just going to keep stretching. It's going to look the same, right? But there's going to be a very big difference when you actually multiply a value of x to multiply a constant to x, and that will actually increase the period. So what happens is that you're actually increasing the asymptotes. You are increasing how it looks like, and then that's about it. And last but not least, when you add a number to the function, you simply just raise it up. So you are changing where it turns, right? Initially, if you look at tangent x, it turns at all these points. Okay, but if you add or subtract, Okay, this is what is happening if you add or subtract. You are in fact just simply shifting. If I add 1, it will just shift everything up by 1. So it will look like that now. If you minus 1, it will look something like that. Okay, so that is what happens when you add. So actually when you multiply to the function itself, it's not going to change anything. But when you multiply to x and you add the thing, your intervals, your range, where it looks like will definitely change. So sketching the graph for this, your period is still 180 degrees because that's how it looks like for one cycle. Okay, your interval is for also about 180 degrees, but now it's from negative 90 to 90 degrees. So you need to sketch it out. Make sure it's in the middle. Okay, what you want to do now is to draw 2 dotted lines. I say again, 2 dotted lines for your asymptote. Okay, somehow make it equal. Okay, you want to make it smaller, also can, up to you. Okay, and you just need to draw it well. Okay, so from here, I'm gonna just draw the graph from here, cut the origin, and go up. Make sure it does not touch the 90 degrees. So it's not touching. It is not touching. So since it's not touching, we have our answer here, which is simply y equals to tangent x, and this here, this is the 90 degree, and this is the negative 90 degree. So you have drawn from negative 90 degree to 90 degree. So that's how you sketch and even understand what is tangent graphs of tangent functions.